Since its monumental launch in late 2021, the James Webb Space Telescope, JWST, has revolutionized our grasp of the cosmos. It's not just a successor to the Hubble. Webb has opened an entirely new era of astronomical discovery. But now, something deeply unsettling has emerged. This marvel of human engineering has detected phenomena so baffling, so beyond the edges of modern science, that some of the world's top physicists are calling it a crisis in cosmology. What if everything we thought we understood about the origins of the universe is, fundamentally, flawed? Welcome to Infinity Beyond, where we journey through the mysteries of deep space and challenge the boundaries of human knowledge. Today, we delve into the unsettling implications of James Webb's latest findings, from impossible galaxies to signs that life might not be as rare as we once believed. Let's begin with one of the telescope's earliest and most shocking discoveries, the so-called impossible galaxies. These ancient galactic structures appeared less than 300 to 400 million years after the Big Bang. Too early, too large, and too well-formed to fit any accepted model of galaxy formation. These aren't faint smudges either. Some of them are as massive as our Milky Way. According to conventional cosmology, such galaxies simply shouldn't exist that early. So how are they there? Scientists scrambled for explanations. Some speculated that the telescope's calibration might be off. Others suggested gravitational lensing could be distorting the data. But as more of these ancient galaxies kept appearing, consistently and across multiple Webb observations, it became clear these were no anomalies. The James Webb Telescope had essentially punched a hole in the timeline of cosmic evolution. But that was just the beginning. Webb then turned its gaze toward several exoplanets, and what it found there was equally astonishing. One candidate, a super-Earth orbiting in the habitable zone of its star, showed distinct signs of water vapor in its atmosphere. If confirmed, this could mark one of the strongest pieces of evidence yet that habitable, potentially life-supporting worlds might be far more common than we dared to imagine. And then there's the case of the so-called dark stars, a mysterious theoretical class of stars that Webb may have spotted for the first time. These objects, instead of shining from nuclear fusion like normal stars, would be powered by dark matter interactions. If verified, this could open an entirely new chapter in astrophysics, revealing that dark matter isn't just a gravitational force. It might actually be capable of sustaining stellar objects. The consequences of these findings ripple far beyond astronomy. If the early universe is more structured than predicted, our entire understanding of physics, time, and space could be in question. Astrophysicist Avi Loeb suggests that we might be glimpsing a deeper layer of physical reality, something hidden beneath the surface of what we once considered the cosmic truth. Others argue this might be a sign that our measurements of the universe's expansion, based on Hubble's constant, are deeply flawed. There's even speculation that we may be dealing with multiple inflationary events, or entirely different types of Big Bangs occurring in a multiverse landscape. At Infinity Beyond, we believe science thrives not in certainty, but in curiosity. What James Webb is showing us isn't failure, it's evolution. The universe is asking new questions. It's up to us to listen. So stay with us as we explore each of these paradigm-shifting discoveries in detail in upcoming episodes. From alien biosignatures to galactic archaeology, we are only just beginning to uncover the cosmic mysteries Webb is unveiling. Don't blink, because the universe is revealing its secrets faster than ever before. In our last episode, we uncovered how James Webb is reshaping the very foundation of astrophysics. But that was only the beginning. Now, we dive deeper into the bizarre frontier of cosmic mystery. Dark stars, theoretical giants powered not by fusion, but by dark matter, the most elusive substance in the known universe. What exactly are dark stars? Unlike conventional stars, which burn hydrogen through nuclear fusion, dark stars are hypothesized to be powered by the annihilation of dark matter particles. These hypothetical entities could have formed in the early universe, long before regular stars ever lit up the night sky. Instead of blazing brightly in the visible spectrum, they might emit infrared light, making them ideal targets for the James Webb Space Telescope. And astonishingly, that's exactly what it might have found. Several faint yet massive infrared sources detected by JWST don't conform to the structure or light profile of typical galaxies or stars. A number of researchers now believe we may have seen the first observational hints of dark stars, objects that could be hundreds of times larger than our Sun, but cooler and dimmer than any star ever classified. If these findings are confirmed, it would mean dark matter is more than just a gravitational shadow. It could be a source of stellar fuel, rewriting not just astrophysics, but particle physics and cosmology in one stroke. But that's not all. While hunting for answers about dark stars, Webb also cast its eye on a distant planet orbiting a Sun-like star. The data revealed clear spectral fingerprints of water vapor in its atmosphere, a compelling clue that this world could be an ocean planet or a water world. Imagine a planet covered entirely in global oceans, no land, just endless waves under alien skies. If conditions are right, this could be a cradle for life. And this one is located within its star's habitable zone. This water world isn't science fiction anymore. It's science fact, brought to light by JWST's groundbreaking infrared sensors. These instruments don't just detect light, they decode it, reading chemical signatures across billions of light years like a barcode. That leads us to a staggering question. If water-rich exoplanets are more common than we thought, could life itself be more common too? In fact, many scientists now argue that life may be a cosmic inevitability, not an Earth-exclusive fluke. From the dark voids where mysterious stars lurk, to moist, cloud-covered planets possibly teeming with microbial life, Webb is revealing a universe that is not empty and sterile, but vivid and alive with possibility. Even within our own galaxy, the Milky Way, the number of potentially habitable exoplanets has skyrocketed. Thanks to Webb, researchers now estimate that tens of billions of Earth-sized planets could be waiting to be discovered. But for every answer we find, new mysteries arise. Take the Hubble tension, for example, the discrepancy between the universe's expansion rate as measured via nearby supernovae versus the cosmic microwave background. James Webb's precision data may help resolve this tension, or make it worse. If Webb confirms early galaxies that shouldn't exist and dark stars that shouldn't be there, we may be looking at a flaw in the standard model of cosmology itself. It would mean the equations that describe the early universe, our cosmic birth certificate, are incomplete. And so we stand at the edge of the known, not in fear, but in awe. Every image Webb beams back isn't just a photo, it's a message from the past, from the edge of time itself. And those messages are telling us we've only just begun to understand the true scale and strangeness of the universe. Here on Infinity Beyond, we'll be breaking down each of these revelations in upcoming episodes. From the mechanics of dark stars to the chemistry of alien oceans, we're entering a new era of space exploration, one driven not by what we know, but by what we are finally bold enough to question. Stay curious, stay inspired, because James Webb is just getting started.